Hello everyone, welcome to the part 7 of our computer graphics lab experiments. Today we are going to look at Bezier curves. So Bezier curves are these amazing curves which are used to generate fonts and generate shapes in automobile industries. For example, Renault used Bezier curves long time ago for the first time to develop their car models. So Bezier curves are these interesting curves which use a few control points to draw the curves. So let's look at how Bezier curves look like. I'll use GeoGebra here, which is this is an online version of GeoGebra, to draw a simple Bezier curve using 3 points. So let me go ahead and select the 3 points. My point A, B, and C right here are the 3 points that I'm going to start drawing my Bezier curves with. I'm going to draw segment AB and segment BC. So let me go ahead and do that. AB and BC. Alright, I've drawn my segments AB and BC. So after doing that, I have to introduce a parameter. So Bezier curves are based completely on parameters and recursive application of parametric equations. So I'll show you what that exactly means in a while. So let me define my parameter right here. The name I'm going to give is t. It starts from 0, maximum is 1, and increment, let's keep it smooth, 0.01. Alright, so that's my parameter t. Now I have to define point on line segment AB and BC. This point will follow the parameter t, and the parametric equation for that point is this little equation that I'm going to type here on the left side of your screen. A into 1 minus t plus b into t. Alright, so that's my point Q. And I'm going to define a similar point on line segment BC. So this let me slide and show you that the Q moves as the parameter changes, because Q is dependent on parameter t and the start and end points A and B. So Q is going to be at A when t equals 0. As you can clearly see in this equation, when you input t 0, only thing is left is A, and when t is 1, the only thing is left is B, because 1 minus 1 will be 0, so A component will vanish. So Q is going to trace the path between A and B using the parameter t. Similarly, I'll have a point R which will trace a path between B and C, and it will start from B and go towards C, and we are going to use the same exact equation right here again. B into 1 minus t plus c into t. So let me go ahead and enter that. Let me select R settings and change the color of R because it's not that visible. And as you can see, Q and R both change as the parameter t changes, because they are dependent on the parameter and their endpoints. Alright, so now I'm going to go ahead and draw a segment between Q and R. So there you go, that's the segment. So let me select that segment, change its color, let's make it violet, purple, whatever you want to call this, lavender. Alright, so okay, I'll slide the T again to show that the line segment changes as you change the positions of Q and R depending on the parameter T, as Q goes from A to B and R goes from B to C. So initially the line segment is just AB, then when t equals 1, the line segment becomes BC. So that's how the line segment moves. And now what we're going to do is similar to how we move Q on AB and R on BC. We're going to have a point, let's say L, and move it on QR using the same formula, same parametric equation, Q into 1 minus t plus R in t. Alright, so that's my point L. I'm going to select and change its color again because this color really looks boring. Alright, what should I color it with? Orange, fine. Let's go ahead with that. So now when I change T, my Q and R positions change on AB and BC respectively, and L also changes on QR. All of these use the same parametric equation and the same parameter at the same time, and that's why you see this movement which is sort of happening in this coordination, which kind of looks beautiful, and it'll look even more beautiful when I do what I'm gonna do right now. I'm going to right click L and make it show the trace of L as the parameter changes. I'm going to click on this play button so that the t changes smoothly from 0 to 1, and then it will go back. And that, everyone, that curve that you see right now, that L traces the locus of L as it moves on QR due to the movement of QR on AB and BC, that is the Bezier curve. Isn't it beautiful? This is what is used to develop new fonts, to develop shapes of cars and automobile industries. Those smooth cuts on your cars that you see, those are Bezier curves. You cannot get it any other way. So quite interesting, isn't it? Alright, so what I'm going to do now is I'm going to stop this animation. I'm going to delete a few things because they are quite unnecessary. Alright, let me keep as many things as possible. I'm going to add a new point D and show you how to draw a Bezier curve which uses, that was a mistake, I'm sorry, which uses 4 points. So I'm going to connect C and D. Alright, I'm going to keep this as it is, and I need to have another point on CD which does the same thing that Q, R and L is doing right here. I'm going to rename L as L1 because I'm going to name the other point L2. You'll see it soon. L1 looks better. What just happened? Okay, Control Z, fine. Okay, so I have QR. Now I define S equals to C into 1 minus T plus R into T. Is it R? No, it's not R, I'm sorry, it's D. So there you go, you have your point S, and again Q and R are red in color. I'll make S red too. Let me go ahead and make it red. Alright, it's red. Hopefully, yep, it's red. So now I'm going to draw the segment between R and S. Segment R, S, perfect. Now again I'm going to draw the parameter on RS, which I'm going to name L2, and using the same parametric form on RS, 1 minus T, R into 1 minus T plus S into T. Perfect. So that's my point L2, and let us change its, why does this keep on happening? Okay, Control Z. Let's change its color. Okay, I had selected the segment option before, so that's why it's happening. So the color is orange now. Alright, so as you can see now, the L1 and L2 trace a curve, but that's not what we are looking for when we have 4 points. So when we had 3 points initially, we had 2 endpoints A and C which lie on the curve, and B was a control point. Now we have 2 endpoints A and D, and B and C both are the control points which give the curve its trajectory, which control the trajectory of the curve, and that's why they call the control points, of course. And now we're gonna draw the segment between L1 and L2. So let me draw the segment between L1 and L2. Let me right click L1 and disable its show trace, because that's not the trace we want anymore. We want the trace to follow path from A to D using B and C. That will be our point L, which will be a parametric form made using L1 and L2 plus L1 into 1 minus T plus L2 into T. That is my L. And let me change the L to something nice. Which color do you want? Green. Okay, let's make it dark green actually. Perfect, cool. Now I'm going to right click L, click on show trace, and of course T is 0.67 now, but I'm going to start the animation, and you'll see that the point L follows this beautiful path from A to D. So the animation is going back towards 0 from 1 now. You'll see it going forward from 0 to 1 again. So A to B, as it's tracing this beautiful path using B and C as the control points and A and D as the endpoints. Now what's more beautiful is, I'm going to stop this animation and let's remove this trace. Let me remove this trace again. So what I've done now is I've changed the position of C and D, and look at what happens now. So again it's using B and C. So remember, B and C are control points and they do not lie on that curve. They just give the curve its characteristic shape. They control the direction of point L, and every point which is moving right now, Q, R, S, L1, L2 and L, all of them use the same parameter T and the endpoints to trace their respective motion. So as you can see, L is tracing this beautiful path. Now if I change the position of D to here, you're gonna see a change in the path. If I change the position of B here, you're gonna see a change in the path. It'll take some time to trace it, obviously, but as it traces, let me change the speed. Well, changing the speed will in fact not help, because it won't show you all the points. So that's the Bezier curve, and A, B, C, D are in that configuration. Again, A, B and C are not on the curve, although you can see that C might be very close to the green dots. It's not exactly on the green dots, and that's what Bezier curves look like. So I wrote some Python code which does the exact same thing. I had a Bezier class and I had functions inside it which take let me run it and show you what exactly happens. Function inside it which use tkinter. So I click to draw points, then I right click to make segments between those 2 points, and I have a slider up top here which goes from 0 to 1, and as I slide you can see our points Q, R and S, L1 and L2, and the L point is traced as this yellow curve. L point traces this yellow curve. That yellow curve is the locus of that point, and that's the Bezier curve. I can show you another configuration. Let's say something like that. Alright, so that's what happens in this situation. A nice curve right there. That looks like Nike symbol. Alright, so that's what Bezier curves are. They are these curves that follow a few control points and endpoints and make this beautiful trajectory of a curve. And of course you can extend this to greater number of points. You can have 5 points, 6 points, 7 points, any number of points which follow this Bezier curve logic, where we have 2 endpoints and the rest of the points are the control points. Of course, to do more than 4 points, to code more than 4 points, you cannot just directly use normal approach, which is just writing down the equations. You have to use the de-Castle-House algorithm, which basically generalizes everything and makes it much more easier for you to code that multi-point Bezier curve that you want. So this is about Bezier curves. Thank you all for watching it so far.